Hello, and welcome. It's March 2nd, 2026, and just 4 hours ago, something extraordinary happened. At exactly 9:15 UTC, the James Webb Space Telescope went dark for 47 seconds. NASA initially called it a guidance sensor glitch, but that explanation was wrong, dead wrong. What actually took place is something far more mind-blowing, and the implications could change everything we think we know about space, technology, and even the laws of physics. Imagine this. The most advanced telescope in human history, the James Webb Space Telescope, sitting at Lagrange point 2, suddenly stops transmitting data to Earth. It's not pointing at a star, it's not pointing at a galaxy. It locks its high-gain antenna onto something completely unexpected, an object from deep space, 3I Atlas. And for those 47 seconds, something incredible happens. The flow of data doesn't head down to Earth, it goes up. Think about that for a moment. In the entire history of astrophysics, we've been the ones doing the observing. We take the pictures, we collect the spectrums, we analyze the data, but this time, for the first time, the universe reached back to us. For 47 seconds, 3I Atlas sent a signal, one that bypassed the encryption keys of a $10 billion telescope. Now, you might be thinking, could this be a glitch? A software error? A cosmic ray strike? That was my first question too. As a physicist, I'm always looking for the simplest explanation, but when I dug into the data logs that were recently leaked from the Space Telescope Science Institute, that simple explanation crumbled. Cosmic rays create noise. They don't create coherent command strings in C++. They don't issue valid instructions that could override the telescope's systems. No, what we saw wasn't random chaos. It was deliberate. The signal that hit the James Webb Space Telescope didn't come from some random event in space. It came from 3I Atlas, a comet, or so we thought. But there's one problem with that theory. Comets are icy rocks. They don't emit coherent radio bursts on specific frequencies, especially not the exact frequency used by NASA for secure uplinks. That frequency? 25.9 gigahertz. To hit that frequency by accident would be like trying to throw a dart from New York City and hit a specific coin in Tokyo. Statistically impossible. Let me put this in perspective for you. The odds of a natural radio source hitting the exact frequency needed to communicate with the James Webb Telescope are 1 inch, 400 trillion. That's not just a small number. In physics, when the odds are that low, we don't call it a coincidence. We call it a signal. We call it evidence. And right now, as I speak, engineers at NASA's Goddard Space Flight Center are scrambling to regain control of the telescope, but I fear the damage, or perhaps the exchange, is already done. 3I Atlas initiated a connection with our technology. For nearly a minute, it didn't just reflect sunlight, it interacted with our instruments. And the question that keeps me awake at night isn't how this happened, although the physics of it all is mind-bending. No, the real question is, why? Why would an object from deep space need to access the calibration files of our planetary sensors? This is not just a glitch, this is not a coincidence. The silence of the universe was broken today. To understand the magnitude of what happened at 9:15 UTC, we need to first understand 3I Atlas. When astronomers first cataloged this object in December of 2025, they thought it was a standard, long-period comet, a chunk of frozen ice and rock from the Oort cloud. Simple, predictable, but as we studied it over the last few months, the physics didn't add up. We watched it accelerate without a tail. We watched it maneuver without outgassing. And then today, the James Webb Space Telescope didn't just observe 3I Atlas, it was interrogated by it. This first part sets the stage and grabs attention with a powerful hook, laying out the core mystery surrounding the event. The tone is consistent, factual, and keeps the viewer engaged. I'll continue with the next part shortly, ensuring the flow remains seamless. Would you like me to proceed with the next part? Now, let's break down the sequence of events that took place, because the timeline is the evidence we need. At 9:14 UTC, the James Webb Space Telescope was transmitting routine science data to the Deep Space Network Station in Canberra, Australia. It was a tight beam, a focused stream of information sent back to Earth as it always does. But then, at 9:15 UTC, something remarkable happened. The signal was cut. The telescope's communication system physically turned its high-gain antenna away from Earth and locked it directly onto 3I Atlas, which was traveling inbound at 44 kilometers per second. Pause for a moment and think about what that means. A telescope doesn't just decide to move on its own, it follows commands. The only way for the Webb telescope to change its orientation is if it receives a command from NASA's Space Telescope Science Institute in Baltimore. But when I examined the logs, I found something shocking. Baltimore didn't send a command. The telescope wasn't following orders from Earth. Instead, the command came from the object itself. And this wasn't just a glitch in one computer system. We have triple confirmation of this event. NASA's Deep Space Network monitored the carrier wave drop to 0, confirming something was off. Simultaneously, ESA's station in Malargüe, Argentina, detected a massive spike in K-band transmission power directed away from Earth. And just minutes later, the Green Bank Telescope in West Virginia released independent radio spectrometry data showing a coherent narrowband signal originating from 3I Atlas at the exact moment Webb lost connection. These are not coincidences. They're the kind of data that cannot be ignored. 3 different space agencies spanning 2 hemispheres all detected the same thing. The telescope was hijacked, but it gets stranger. The signal that 3I Atlas used to seize control wasn't just a random burst of noise. It was a handshake, a term used in computer networking for an exchange of protocols. In simple terms, it's like saying, "Hello, can we communicate?" But this wasn't just any handshake. In order to communicate with NASA's spacecraft, 3I Atlas had to know the frequency, 25.9 gigahertz. It had to know the modulation, phase shift keying, and precise timing. The odds of a comet, a simple rock in space, accidentally matching these specifications are so low, they're practically non-existent. To make it clear, the probability of this happening is effectively 0. It's statistically indistinguishable from magic. What does that mean for us? It means that this wasn't just a random event. It was deliberate. It was intentional. Someone or something executed a digital handshake with NASA's most advanced instrument, and the implications are staggering. So, what actually happened during those 47 seconds? According to the initial reports from the flight operations team, there was bidirectional data flow between the telescope and 3I Atlas. In simple terms, that means data wasn't just being downloaded from Webb, it was also being uploaded. But here's where it gets really chilling. When we examined the telemetry packets exchanged during those 47 seconds, something alarming appeared. 3I Atlas didn't just ping the telescope. It accessed the fine guidance sensors, the eyes that tell Webb exactly where it is in the universe. These sensors are responsible for navigating the telescope, keeping it locked onto its targets in space. 3I Atlas not only accessed the star catalog, the internal map that Webb uses to navigate the cosmos, but it also took our navigational data. Now, think about this. If you're a visitor entering a new building, what's the first thing you look for? A map? right? You need to orient yourself. You need to understand where you are. And for 47 seconds, 3I Atlas made our most advanced observatory hand over its map of the stars. This is unprecedented. It's one thing to observe an object in space. It's something else entirely for that object to access and manipulate our technology. And then there's the power behind this interaction. To transmit a signal strong enough to override a high-gain antenna millions of kilometers away, you would need an immense source of energy. A comet has no power source. It has no solar panels. It has no nuclear reactor. Yet, the signal strength measured by Greenbank was off the charts. Where is that energy coming from? How is 3I Atlas generating such a strong signal? The more we dig into this, the more the laws of thermodynamics are being tested. We know that energy is conserved. It doesn't just appear out of thin air. But for 3I Atlas to generate that kind of power without any apparent energy source, that suggests an internal system far beyond anything we can comprehend. It's as if this object is using a technology that we're not yet capable of understanding, a technology that could have implications far beyond space exploration. Now, let's examine the moment when the connection was finally terminated. At 9:16 UTC, the connection was cut, but not because the signal faded. No, the transmission ended because it was complete. The telescope's high-gain antenna rotated back toward Earth, and normal data transmission resumed as if nothing had happened. But something did happen. The damage, or perhaps the exchange, was done. When NASA engineers pulled the logs from the solid-state recorder, they found a file that hadn't been there before, a file that had been uploaded to the telescope from 3I Atlas. This wasn't just any file. It wasn't science data or an image. No, this file contained a sequence of prime numbers encoded in binary, repeated 137 times. Now, why is that significant? In physics, 137 is a special number. It's known as the fine structure constant. This number defines how light interacts with matter. It's a universal constant, a building block of the laws of physics. To find that specific number encoded in a file uploaded from an object in deep space, that's not a coincidence. It's a message. Someone or something is saying hello, or perhaps they're saying, "We see you." This discovery raises more questions than answers. Who or what would send a sequence of prime numbers from deep space, and why 137? Is it a sign of intelligence, or is it a signal from a civilization far beyond our own? But the story doesn't end there. There's more to the mystery of 3I Atlas, and the data we've collected over the past few months is just the tip of the iceberg. When we look at the trajectory data from the Jeepsalson laboratory, one thing is crystal clear. 3I Atlas is not falling toward the sun, it's driving toward it. You see, a normal comet is a passive traveler in space. It's pulled in by the sun's gravity, and as it gets closer, heat causes the ice and gases to sublimate, creating a tail. That's what we expect to see from a comet. But 3I Atlas is different. There's no tail, there's no outgassing, it's not behaving like a normal comet. And when the James Webb telescope trained its NIRCam instrument on it for 10 hours, it didn't see dust or gas. It saw a solid, metallic surface with an albedo of 0.8. That means 3I Atlas is reflecting 80% of the light that hits it, which is far higher than any normal comet. In fact, it's shinier than polished aluminum. So, if there's no outgassing, no rocket-like propulsion, then what's making this object accelerate toward the sun? The laws of physics tell us that a mass of 33 billion tons, like 3I, Atlas needs a tremendous amount of force to accelerate. But there's no traditional force acting on it, no solar sail, no gas jetting out. No known mechanism in classical physics can explain this. That is, unless we're missing something, unless our entire understanding of physics is incomplete. As we continue to examine the data, we're confronted with the growing realization that the physics of 3I Atlas defies all expectations. The object seems to be interacting with solar radiation pressure in a way that shouldn't be possible. It's as if it's using a propulsion system that doesn't rely on photons. Maybe it's manipulating magnetic fields or using the solar wind's charged particles directly. And then there's the rotation. For weeks, 3I Atlas was tumbling chaotically with a rotation period of 8.2 hours. But just 12 hours before the Webb incident, something incredible happened. The rotation stopped completely. In space, momentum is conserved. A spinning object doesn't stop spinning unless a force acts on it. To halt the rotation of a 3 billion ton object in less than an hour would require an immense counter-torque energy equivalent to a tactical nuclear weapon, yet 3I Atlas didn't shatter. It didn't break apart, it simply stopped spinning. Where did that energy come from? What stopped the rotation? And why does the object remain cold, even though its momentum was abruptly halted? These questions challenge everything we know about physics. But the most terrifying possibility is this. If 3I Atlas is not just a comet, if it's a probe, a vessel, then it's much more advanced than anything we've ever encountered. And it's been sending us messages, the countdown, the prime numbers, the gravitational anomaly. It all points to one thing. 3I Atlas is not just watching us, it's interacting with us. And the question remains, what happens when the countdown hits 0? We don't have much time to find out. The clock is ticking, and the answer is closer than we think. Stay tuned as we continue to follow this incredible story. Subscribe and turn on notifications because the countdown is happening right now. In less than 14 hours, we'll have the answers we've been waiting for.